所有人炒股都想获得长期稳定的投资收益，但是很少有人能做到。即便是对于专业的机构投资者来说，似乎也是很大的挑战。股市的规律似乎很难被把握，因为这背后有太多纷繁复杂、互相关联又互相影响的因素在左右着市场的走势。同时，每天又会产生大量的交易数据、突发事件和新闻消息。想要分析所有的这些数据，准确地把握其中的规律，已经远远超出了人类的能力范围。同时，在微软，我们看到人工智能技术已经在很多领域达到甚至超过了人类的水平。那么我们有没有可能利用人工智能来帮我们理解股市，获得投资判断的依据，进而提升投资收益呢？在一个万事万物数字化的时代，利用计算机去构建数据模型，进行量化投资，这是证券投资的大趋势。而微软亚洲研究院利用人工智能的技术对金融投资进行跨界研究，则涵盖了量化投资的全过程，让用户可以更容易地利用人工智能的算法来辅助解决量化投资的各个关键问题。授人以鱼不如授人以渔。在2020年底，微软把这些跨界研究的成果打包，发布了 AI 量化投资平台 Qlib， 而且在 GitHub 上开放了源代码。作为一个开源工具包，不管是金融机构还是个人从业者，都可以利用这样的平台来提升投资的能力水平，构建属于自己的智能量化投资体系。
Just a demonstration or just a overview of what Qlib is, and I'm just going to take it straight from what the creators of this actually says. So they say with Qlib, it's very easy to build a complete quant resource workflow and try your ideas with Qlib. And then they also say, which I think is a pretty bold claim, they say though with public data and simple models, machine learning technologies work very well in practical quant investment. So basically they're saying, with kind of not that much effort and pretty cheaply, you're able to actually create, realistic practical models. And I think if I had just said this, and I'm just talking, as who I am, a lot of people will probably be pretty skeptical. But this isn't my words. Or if you want to fight somebody about this, you can fight Microsoft Research. This is actually the team that created Qlib. And so when I hear that it's from a place like Microsoft Research, which has pretty impressive background in machine learning and AI, it doesn't necessarily mean that it's the greatest model. Doesn't even really necessarily mean that it's a good model. But in my opinion, it means a couple things when it comes from a big place like this, like a Facebook or a DeepMind. It means that there was a lot of resources that went into this, and it means that generally, I held it in slightly higher regard than if just somebody random by themselves said that, somebody like me, to be honest. So I'd be skeptical if somebody like me had said this, but I'm really interested to take a look and see. And I'm actually going to go through, and I'm pretty impressed with this library and how easy it is to really create end-to-end quant investment models. And what I mean by end-to-end is really that, like every single step that you can think of, from getting the data to training your models, back testing and evaluating your models, and then actually generating the orders. And this library really has it all, and it's kind of the one Python library you need in order to have quant investment. And it's also really, really powerful, because this model training is not just linear models or scikit-learn, or not to disparage scikit-learn or anything, but you can do very powerful deep learning models in both TensorFlow and PyTorch. And so we're able to actually really, really use the cutting edge models and cutting edge technology, and really a very convenient framework. And so just based on what they have, you can actually create kind of any model that you want, but they have pretty good, backgrounds that are you can just pull a bunch of gradient boosting tree algorithms. Let's use LGB, Light GBM, XGBoost, multi-layer perceptron, basic neural networks, GRUs and LSTMs. I went a little bit more into LSTMs in the last video, but GRUs are very similar to LSTMs. They're a tiny bit simpler, but they still work out very well. In some tasks, they actually end up doing a little bit better than LSTMs. We have attention-based LSTMs, graphical models, and some other models as TensorFlow-based models. And so there's a lot of different models that you can use, and really powerful models. They actually don't have here. There's actually a linear model. If you just want to do a baseline linear model. And so, but these are trained, it's really kind of easy. And we'll actually go into this, show how easy it is to actually just, let's train an LSTM on our data set. And so this is just a depiction of some of the results. This is basically on their benchmark. They have the Alpha 360 data set. So this is actually based on the Shanghai 300 data set. They have the Shanghai 300 and also I think the S&P 500 as like kind of pre-built-in data sets, but you can actually upload any data set you want. We're going to be uploading our own data set in the next video. Right now, we're just going to be working with the Chinese 300, the Shanghai 300 video, or the Shanghai 300 data. But I think the most, we went into some of these kind of ranks beforehand. I think just probably the most intuitive to look at is just the annualized return. Linear model actually doesn't work out so well, so let's maybe not use that. It seems pretty bad, but I guess for the other ones, positive multi-layer perceptron kind of makes sense. It's a pretty simple model, and I don't think it's really suited for like time series data like LSTMs or something. But like if you see GRU. GRU actually, performed one of the best with these graphical models also coming in. So these ones are generally, kind of better. I'm surprised that the attention LSTM didn't do as well as the LSTM. I think it might have just been a problem with the data set, but we'll see. Essentially, this is just their benchmark data set. We're going to have to try, or, you should try a few different models and actually determine what's going to work out on our data set the best for our given model. And we're actually going to show how we're going to do that. Today we're actually going to go through, basically they have a demonstration. I highly recommend you check it out, especially it's actually really easy. You just go through their Google Colab notebook and you'll be able to actually run it without really installing anything and then after I show the kind of that, we're going to actually show, there are some things to keep in mind when you're installing it. Actually took me a while to just figure out how to install it, and I think might have just been a personal problem, but hopefully some of my notes will make it easier for some of you watching. But then we'll also go into, once we get we're going to actually tune the LSTM parameters, like how do we actually get the best model for it. And so that's what we're going to take a look at. So. All right, so this is just the Google Colab notebook. You can access this if you go in the description below. Basically, this is just a nice sort of Python interpreter that we can run on our browser, so we don't actually have to download or really run anything right now. We're going to go into how to actually install it and run it locally, which is what you're going to want to do if you're actually going to implement this yourself. But I think if just for a demonstration, kind of looking at it, we're going to go through this demo, and then we can kind of see how we can change, just the part that we need to actually make an LSTML that we were talking about. So basically this first one, if you haven't already run this, probably a bunch of things are going to pop up. Basically you just run this. You only need to run this block once really. So this is just going to download this script called getData.py, which is going to be used to, guess what, get the data, right? So basically this is just going to get this getData.py. So then this is where you import your modules. Nothing too exciting. Just kind of, you can go through the GitHub and kind of go through all the modules if you want. We're not going to really do that right now. Here, this is saying you download your data that we're going to use. So we're here, this demo is using this Chinese data, the Shanghai 300 data. They also have the US stock market data as well. But at least this one is for the Chinese market. And so this is, that's where we say here, you would say like US or S&P 500 or something for the S&P, but we're not going to do that right now. So this is data handler. So this is just telling us from 2008 to 2020. So we have around 12 years of data, and obviously we could change this if we wanted to. Why not? Let's just make it a, like you said, that's like a 9, 10. Why not? I mean, you don't have to change that, but we'll see. I guess it doesn't matter. I should change it here too, because I should have set the testing set. I'm not going to mess with it. But basically, this is sort of the main block here. And I think if you'll see how this is really what we're going to focus on today, right now. And so this is just our task block. So we have, this task is defined by a model and a data set. And so our model here, we would say like LSTM. By the way, I ran this and this is running. We'll probably have to come back to check on the results. But I'm running right now this light gradient boosting model. And so these are our different parameters. I'm not going to go into these because these aren't important. We're not really discussing these models right now. But basically, we define our model here, and then we have our arguments. We're going to go into every single specific argument of the LSTM. We're going to show how we can use our arguments of our LSTM to actually improve our models, and we'll see how to get the best models. And then once we're ready, we can do kind of all this other stuff where we get our data from what we had last time, and we'll be able to actually incorporate all of our data from last time, have an LSTM model in this framework. framework and then easily be able to do everything else like back testing it and actually applying it. So we'll come back in a little bit and we'll see how this actually ends up looking like. So our model ran. These are the results. We have training accuracy, or actually I'm pretty sure this is loss. Yeah, it's loss definitely, because if it's MSE, mean squared error, because that's what we defined right here. But basically, the lower, the better. So as we train overall, our training is slower, but our validation kind of has a shape where it kind of goes up at least a little bit. So they determined 127 to be the best iteration. Has the lowest validation loss out of all the ones that we see here. And so then the next segment, all you have to do is, for the demo, obviously you just kind of run it, but basically it's pretty easy from here to using this whole framework. You kind of ran this model, you saved it. It's really kind of easy to take this and you can just run your prediction and your backtest analysis. So with your model prediction, you're basically saying how good is it coming in the future. So these instruments are the actual stock tickers in the Shanghai. That's how they're actually labeled in the program, and we'll kind of see a little bit of that in a second. But basically, if you want to look at the sort of backtested return, it was really easy. We just trained a model, and then we were able to actually backtest it here. So the mean standard deviation of our returns and our annualized return is here. This is the mean is of the excess return over our benchmark essentially. And so this is actually, it looks like pretty good models. I'd be a little bit skeptical, to be honest. I think it still might be a little bit overfit, but we'll see. But yeah, basically, again, if we can change this block here, we change our model, we change our data set. The rest of this is kind of the same. So we can, and they actually do have modules for you to just run all of the models that you have from the LSTM and just figure out which the best one. So I like these pretty little graphs because they make me feel smart when I make them, even though, again, all I did was just run this from the demo. But basically, yeah, just run these here. Yeah, so then this is just the from our testing data set, basically what is our cumulative return. So if you remember, so this starts from 2017 to 2020. So that was what, if you remember, I should have said 1010, and this should be a little bit longer, but we can see. But it looks like, you can kind of read this. I'm not going to go into too much detail. It's a lot of graphs and stuff, but you can kind of see how you can get a lot of metrics, and we can get really the back-tested results of what would happen if we incorporated this model right after we finished using the data we trained. And so this can kind of give us a good results, maybe what you would want to do in an experimental pipeline. And I think this is actually, it might be a little bit important to bring up right now. But basically, a large amount of this machine learning is going to be trial and error. And essentially what that means is you're going to just try a bunch of different models. You're going to see which one works best. So the idea, something that you would do here maybe, is you would say, well, okay, we're going to train, validation, and testing set. And then you find out the best model. You say LSTM would be the best model, or attention LSTM would be the best model, or GRU would be the best model, or whatever. You try a bunch of these based on some empirical metric that you ideally should define beforehand. So you should say, really should just say one of these. Maybe like annualized return without cost, or maybe it might be actually very similar to this success risk. But basically, maybe information ratio, as we said before, you can kind of just define maybe even a mean or something, but you want to just define, what is a good important model to you? What would that look like? And then figure out which one's based on your testing set. And then this is the important part, is what you can do usually a lot of times is just train on the entire data set again. So remember, you obviously never want to train and test on the same data set because that will lead to overfitting. But once you decide the best model and you tuned your best model and you said, okay, I'm ready, I think that the LSTM model will work best in the real world, what we're going to do is we're actually going to train on the entire data set again. And then that entire data set will be used to predict the next step. But basically, this is just as if we had stopped again at 2017 and then how it would look overall. And so with cost is kind of, we can specify what kind of sort of costs there are to trading basically here. And so, yeah, and that's essentially it. We can kind of see over time we get our excess return information ratio, and so this is all kind of useful for really analysis. I think that once we actually get to this point, we're gonna have to figure out good ways to actually decide which one of these is the best model. I definitely highly recommend looking into all these. I'm not going to spend too much of this time because I think we're going to do a little bit more into this later. So autocorrelation, is pretty much the correlation itself. You can check out my time series video if you want to learn more about that. So basically, we can kind of show that, well, now this is our sort of way to evaluate all this stuff that I just showed you, this analysis and prediction, is our way of basically, once we train our models, we're able to actually kind of easily test them, basically, and then we can figure out how to actually predict them in the future, and we can actually predict them here as well, figure out which ones would be the best investment. And so next we're going to go into a little bit more on how to install this, and then we're going to show how we can actually tune the LSTM model to be ideal for what we want it to be. So, all right, so I actually spent an embarrassingly long time trying to figure out the best way to get this installed, and I'm still actually kind of working out some kinks, which is why this is not going to be a complete video today. But basically, here's at least some things that I've kind of struggled through, so that you don't have to struggle through them too while you figure out how to install this. It's better on Linux. I would just use a Conda environment no matter what. If you don't know what that is, just Google mini Conda or Anaconda, figure out how to install it on your operating system. You want to clone it through the GitHub, and then that has a lot of scripts that you can use that will kind of be a good starting point. And then, so finally, I think really important is just model your parameters based on the examples in the benchmarks. So let's go ahead and take a look at all those things. We're going to start with just the tutorial that I stole from this guy on the GitHub. All right, so this is an installation tutorial. I'm just going to copy the link in this below. Again, you're going to need what he first does is he activates this Conda environment called demo. Make sure things, you need Python 3.7 at least. I would just go with 3.7. I don't know if it works in 3.8, honestly. It probably does, but I'm just using 3.7. Then he uses this git clone of the repository, the Qlib repository. He CDs into the Qlib repository, ls, and then he installs using pip. Make sure, it's just really important you get this GitHub repository and not just install it through PyQuip. And also, just make sure it's not pip install Qlib, it's pip install PyQlib. Just don't forget that, because if you type pip install Qlib, you have to uninstall it and then reinstall this PyQlib. So then you ls and then you CDs into examples. He ls is here in examples. And then he types this command here, basically qrun benchmarks, and he pretty much says this workflow. So you specify this workflow file, and then he's able to just say, you file directory. We're going to go into a little bit more how we can just say qrun, LSTM, and it runs on our data. And so this is the exact same thing that we had before, very similar. So the same things that they pulled up over there. So let's go ahead and take a look at how to actually use this, and we'll see how we can do this with actually LSTMs. All right, so this is just our bash terminal. I'm actually using the Ubuntu shell in Windows, so I actually highly recommend you doing this. It's a pretty big file, but having Linux on my system is really easy, so that's what I'm using here. You can also do this in terminal and Mac. But basically, we're going to use this, and so this is the same sort of system. We're going to CD into our Qlib folder. So we followed the directions before from this terminal. We typed in, all the things that we needed to do. We got our Qlib terminal. We installed Qlib and everything. So then once we're here, we can say CD examples. I can go up a little bit. And so here now we have benchmarks. We can say like qrun benchmarks LSTM, and then we'll do workflow config alpha 360. So so basically we just instead of Q running LGB light GBM, we did LSTM and we said this alpha 360. So we have 6 features inputting, and we'll go a little bit more into those in a second. I actually, by default, this would be 64 hidden size and number of layers too. Basically, it's all kind of a balance. And if you're not super familiar with LSTMs, basically the idea is how many LSTM blocks and how big, you have a certain number of layers. And each layer, you could say 1 or 2 or 3 or 4 or 5, it gets exponentially more difficult to calculate, but it also becomes exponentially more powerful. You're able to model more possible models essentially and identify, but it becomes harder to find the right one. It's basically all just a trade-off. And again, this is kind of what I mean is if you really wanted to make the best model, you would just try a bunch of different things and just see what worked the best, essentially, right? And so that's what you kind of do, and especially now with all the models being so good, it's almost as if like every single, it's just kind of chance if one model is going to be better than another one. Like if the attention LSTM or the GRU is going to be better, it's just kind of chance, to be honest, on your data set. But basically, we're working again with the CPU right now. So we're only going to say hidden size of 16, number of layers of 1, because I don't want to be here all day waiting for this, even though this is still going to take a while. Looks like we got some loading data, but we don't have any dropout. We're going to train for 200 iterations. That actually might be a little bit much. I might actually come back and install that because, again, I don't want to be waiting. If we had a GPU, this wouldn't be a problem to worry about at all. If you have a GPU, then consider yourself lucky. I highly recommend you figure out how to use these when you run your models. It's not entirely necessary because you can just wait forever if you just have a CPU, but you really, if you're going to be training a lot of these models, you really want a CPU. It will make it, no lie, like literally 100 times faster. And you if you find yourself waiting for a lot of things, it's just going to be better. And so, yeah, again, this is like one layer with 16 hidden size. That's a tiny model. And we're still using only a fraction of or we're still going to take forever to calculate this because we're using a CPU. If we had a GPU, it wouldn't be as bad. So the dropout, what dropout is essentially a term that it controls overfitting broadly. It's kind of not really popular anymore. I mean, it kind of is, but it's not as useful anymore. There's kind of better methods, but it can still be useful for improving models. Basically, you kind of forget things in training, and that prevents you from overfitting. They just leave it at 0.0. You can just experiment maybe at 0.1 or 0.01 or something like that. But maybe just leave it at 100. We'll do a little bit of experiment. We'll see how that is. And epochs is how many epochs we're going to train, how many iterations we're going to do. And so it looks like we're going to keep going into more of our results here while that still loads. Learning rate, so this is the LR. So it's basically how fast you want your network to learn. If you learn too fast, you might not be careful enough. You might just, basically it's like how much should you move the network with respect to the data. If you think that, like, having a data point that's, significantly different, what you think that you should really move and like kind of adjust it, that or just tinily over time, basically. It's like how much at one time do you want to adjust your model? And you can think about how if you were being really careful and going really slow, you might just take literally forever, like tens of thousands of years. You'd be stuck in a local minimum or something like that. But if you go too high, you might just be going all over the place and not actually able to learn anything. So again, I'm going to say this again, it's just all of it's a balance. We have our metric as a loss. We have our batch size of 800. We have an early stop of 20. Atom is optimizers. So I guess we'll go back. So loss is just the metric that's going to be using for, or metric is just what's going to be used for early stop. We're just going to say the loss is going to be what's used for early stop. The batch size is how many samples it gets fed at once. You're going to want to make sure that this connects with your D features and kind of works out in a way. Because it's really important that essentially, if you can define the input of your model to be what you want it to be, it's kind of easy to get the output. And so you need to be careful with how you define the input, and the input's kind of defined through a batch size and the dimensions of your features that you're giving it. And so this needs to add up to the right numbers, essentially. So early stop is after 20 iterations. If we don't see an improvement in the loss, we would stop. Atom optimizer. So there's two different options here. You can either do SGD or Atom. Atom is a little bit faster, a little bit more efficient. But if you really want to get a good model and you don't mind waiting a little bit longer, and you probably have a GPU, SGD can be pretty good too. Although you can get stuck in local minimums. So we're not using a GPU here, and we have no seed. So looks like we took some time to. We can kind of see how much to load everything. Yeah, so we'll come back in a little bit. We'll check on this model. So while we're waiting for how to actually run, running these models, let's go ahead and take a look at what the data actually looks at. So this was the sort of data data downloading that I downloaded before. I ran pretty much the same code that is in that demo document, and that we looked at the GitHub, that first line, or those first few lines. And so that was able to just give me this data, downloads this data, and then that's why I was able to do the Q run and all that stuff. But that'll be here. And so basically we can say, we're gonna go look on the features. And so as long as we get it, so this is the list of all the securities we have. As long as we get it in some sort of the format that they want, so let's take a look at SH 603 668. Why not? So everything has a change, a close, high, low, open, and volume. And this factor is, I'm pretty sure that just the adjustment factor, so it's not included. So that's where the 6 features come from. And so, yeah, so basically we just have to make sure, and these bins are special files. There's like different codes. We're going to go a lot more into this into the next video, but basically there's different sorts of codes that we can use that are just really scripts that can convert our CSV files into our formats into this format. And so essentially, yeah, once we're able to do that, we can kind of define however many features we want, however many securities we want, and then we saw how easy it was to just try our model to train that on that. All we had to do, again, to train our model was we say, okay, well, we download this GitHub repository, and so we can go to examples, right? Was it having examples? Yeah, that's where the benchmark is. Benchmarks, LSTM, and then we can like, let's go ahead and say workflow config 360. So this is, let's go ahead and take it. This is actually going to be a look at the workflow that we ran. So this is what we were actually able to use Q run on earlier. So this is, we're going to copy this into a workflow. So this is all, I don't know if, I haven't actually gone over this. This is bash scripting. This is what I'm doing in Linux, and it's kind of helpful for organizing files or running. Like, this is what you want to do if you're, like, you see this, we created all these files. We obviously didn't want to do that by hand, so we have a script. This is the sort of scripting language that we use. We're going to say, this is going to be our copy of our workflow. I shouldn't have done this, should just do that. Okay, that's cool. All right, so now we got this workflow, alpha 360 copy. All right, cool. So now we can, yeah, this is kind of it, right? So we say, okay, well, this was where we had our data. This is our region. This is our, our market. This is our benchmark. And we were able to go down here, and this is very similar. So we defined the back test and the strategy portfolio stuff first. But down here, this is very similar to what we had before in the other in the demo online. And this was all the features that we went over. And so remember, I had 16. So I don't know, we could try 32. We could try 2 layers. It would take forever, so we're not going to do that, but I'm pretty sure that's what the default was. I think the default was actually 64 for hidden size. We figure out what we adjust here. For this case, the data set H is going to be the same. But yeah, essentially, we're able to actually figure out how to easily train our model. And then, again, once we train our LSTM on the data that we wanted to, we can easily apply these backtesting algorithms. And then even going on, they have pretty easy ways to actually just send the order out. And so we're doing a little bit of the backwards work. I could have just started how to do an LSTM in 5 minutes, and I could have just done essentially the LSTM. And if you've been watching since this entire video, you could have saved maybe a lot of time, but we're going to go through all of it. So that way, once it all comes together, you're going to see it all the magic come together. We're going to be able to get from end to end everything we need. So it's exciting. So let's go ahead and take a look at how our model is actually still training. All right, so our model's still training. He's going to be here for a while. It's not that good, especially compared. So I think that there's just a bug that these are minus. I think this should just be not minus. So I think you should just ignore that. Or I think it's saying like train is. I'm not quite sure how that works, but from what my experiments have kind of shown me, I'm pretty sure that this is not supposed to be minus. But yeah, I mean, so that's how we were able to just kind of simply trade it to the LSTM. We could do that with the ALSTM. And then, so now that we have our data and we know how to easily run this LSTM once we have the data, so let's try to get them to work together. We're going to go ahead and look at that in the next video. It'd be easy to actually just go ahead and let's take a brief look at what we're going to do next time. in terms of CSV format. So this is so once we can get it in this format, where it's able to actually easily be able to convert our data to our other format. So if we have here, 3.0, so we have date high open, low volume adjusted closing symbol. So we're gonna have to slightly adjust what we did last time, but it should be pretty easy. And this is, again, looks very similar. We're just gonna have to do this for each individual stock. We'll put it all together, and I look forward to seeing you guys next time.